All right, here's try it 1.30 where we're asked to find the domain of this composite function here, f of g of x. And again, remember that when you're finding the domain of f of g of x, you have to check two things. Anytime you're finding the domain of a composite function, first check the domain of the inner function, and then check the domain of the entire expression. So I got two steps down here. My first step, where'd this thing go? Here it is to check the domain of g, because g is the inner function here. So the domain of g, oh, there's a square root. My domain rules, so first let's figure out the domain of g. My domain rules, there's two things at this point that you have to worry about when you're taking domains. You can't divide by 0 and you can't take the even root, so square root for example, of a negative number. So this thing that's underneath the square root sign, it's called the radicand. The radicand must be a positive number. Mathematically, I could say it must be greater than or equal to 0. And so I have this inequality which I can solve for x. I say x is greater than or equal to negative 4. So the domain of g is all values of x greater than or equal to negative 4, but that's not the domain of the composite function. To figure out the domain of the composite function, I need to first figure out what is f of g of x. And the way I'll figure out f of g of x so I'll start from the inside and work my way out. G of x is the square root of x plus 4. So f of this thing, well here's f of x, so I can figure out f of this thing by copying this, and everywhere I see the letter x, replace it with this thing. So I got 1 divided by the square root of x plus 4 minus 2. Then you stare at this thing. This is your composite function. This is, to refer back to this, the second thing that you need to check, the domain of the composite expression. It's kind of challenging to deal with. I have both of my issues going on. I got to make sure I don't divide by 0, and I also got to make sure I don't take the square root of a negative number. Okay, fortunately, I won't have to worry about taking the square root of a negative number because I'm already restricting my domain to x values greater than or equal to negative 4. I've already accounted for the square root of x plus 4, so that appearing in this is not problematic. But I do have to be careful. I do have to make sure that the denominator here does not equal 0. So I do have to check, when will the square root of x plus 4 minus 2 be equal to 0? Because if this is true, I'd be dividing by 0 here, so I don't want that in my domain. Well, to solve this, you could add 2 to both sides of the equation. So that gives you the square root of x plus 4 equals 2. Can the square root of x plus 4 equal 2? Well, yeah, it could if x were equal to 0. You can show that mathematically by squaring both sides of the equation. And that gets you x plus 4 equals 4. And subtract 4 from both sides of the equation, that gets you x equals 0. When you square both sides of an equation, you kind of lose some information, right? Because this could have been, well, just trust me, when you square both sides of an information, you lose track of the signs, right? Imagine an equation where you have negative 3 on one side and positive 3 on the other. Those two things are not the same, but if you square both sides of the equation, all of a sudden they're the same. So you have to be a little bit careful when you square both sides of the equation. The easiest way around this is just check your answer. Is 0 really a solution to this? Well, yeah, it is, because 0 plus 4 is 4, and the square root of 4 is 2. So it does check out. Anyways, the point that I'm making in all this is our second thing we have to check is the composite expression. And from the composite expression, I get that x cannot be equal to 0. So when I'm figuring out my domain of g, kind of think about it with the number line. I start out with all real numbers. But then up here, I'm figuring out the domain of the composite function. I start out with all real numbers, but then I first consider, well, I need it to be in the domain of g. I need x to be greater than or equal to negative 4. So include negative 4 and everything that is greater than negative 4. But then you have to look at your second criteria, the composite expression, where we figured out that x could not be equal to 0. So I have to open up a circle right here that I don't want included. So my domain will be everything from negative 4 up to 0, union everything from 0 up to infinity. Note that I do want to include negative 4 because this were greater than or equal to negative 4, but I do not want to include 0 in this interval or in this interval because I decided to exclude it down here. So this right here would be the domain of the composite.